Welcome everybody to our session. We want to talk about a simple application and what it means if this application becomes enterprise grade. My name is Juergen Sussner. I'm from Dativ, Germany, a company for tax consultants, auditors, lawyers, and that is not that boring as it sounds actually. So we do a lot with platform and platform engineering. But imagine we have an application. We have a groundbreaking idea for that application, and what if that application suddenly gets really successful? So let's have the idea. I don't know, like the war of IntelliJ or Eclipse. I don't care, I like both. But let's take an IDE, create that application, pick a source code repo, start coding, and you have your application, and you're pretty much done. You have an application, put it on a server with a database. It's usable to anyone else. We're done. Well, at least this is where my hobby projects end at that time. But what happens? The application isn't available because the server itself, the single instance server, is in maintenance. So, okay, I heard about that thing called Kubernetes. It offers high availability. Put that application on a Kubernetes cluster. Okay, I have a high available cluster, 3 master, 3 worker nodes, database here, application there. We have a high available application, but it requires re-architecting the application, packaging in a container, and it requires the knowledge how to configure such a Kubernetes cluster. Okay, next problem. My application is really responding slow. And that might be a problem because the database and the application sharing are the same CPUs. So let's use another Kubernetes cluster for the database itself. I can tune them to more specific hardware requirements of a database, and I tune them to more specific hardware requirements of the application itself. But that requires high available databases. And I have to have the knowledge how to manage a high available database. I have 3 availability zones, I have replication concepts, and I have to know about all that to be able to run such a high available database. So, a friend of mine said this, it's 9 PM, do you know what your clusters actually are doing? No, I don't. I don't know what my Kubernetes clusters are doing at the moment, and I have to add monitoring. For the sake of this demo, let's say, okay, we add another cluster that has all the monitoring logic on it. Can be Prometheus, can be Grafana, can be whatever monitoring system you can imagine. But it requires to know how to operate this in a high available fashion. This should not be bundled with this because this can fall apart. I still want to have the monitoring information. And I also have to have the knowledge about dashboard design and all the stuff that's written down here, how to act in an emergency. So I have a pretty complex setup, but guess what? How did we deploy to that? I can start deploying using kubectl on my private machine, but that's not how I want to deploy software. I usually use pipelines. So okay, I have pipelines. Well, it requires good unit tests, it requires understanding of pipeline technologies using Jenkins, Tecton, GitOps flows, whatever, but it requires the knowledge of all these methodologies, and it also requires some sort of CV management, for example. I have to check if my application is still secure. As I said, unit test, integration, I have to care about rolling deployments. How do I do rolling deployments? How do I avoid downtimes at all? And it requires specific tool know-how, so a lot of requirements with that. And one point I want to point out is the license management. Especially for enterprises like us, we can't use every open source license because it sometimes would require us to open source our software itself. So we have specific requirements using only specific open source licenses in that process. And again, how do we manage all the clusters? The clusters should be aligned to certain policies. So I would need a cluster management solution as well. I can build it up on my own using Flux, for example, or Argo, or I can just buy one for the sake of its demo. Let's see, I build it on my own. But it requires a definition what is common to all my clusters. And so there are a lot of more things you can add, maybe identity gateways, maybe IDS or IPS systems, just to protect your assets even more. And there is much more to come on this. If you think of compliance policies, like being a C5 certified, like going multi-cloud, like having global load balancing, like having this environment not just once, but once per stage, a dev, a QA, prod stage. And you will end up in a quite complex setup. So the issue is what I really wanted to do was creating that simple application. And where I ended up was all that stuff. 5 Kubernetes clusters, I know knowledge about monitoring, metrics, cluster maintaining, pipelining, identity gateways, and no idea about compliance or certifications, for example. This is where I ended up. And that is where everyone will end up when trying to create enterprise-grade applications. So there's a research from MongoDB and Stack Overflow that says you spend up about 40% of your time in developing your application, so 2 days a week of development, and the rest of the week is meetings or management of infrastructure. And how will this scale to, let's say, 100 teams, 500 teams? This is simply not possible for larger enterprises. And if you look at the Cloud Native Computing Foundation, Kelsey Hightower says, just build a platform. It's never been easier before. Just look here, pick 200 tools, and you're done. Maybe it's probably not that way, but let's hand over to Marcus. He will show you what can be done.
Thank you, Juergen. Hi, my name is Marcus, so I'm the pre-sales architect for Datev, responsible. So in many decisions and discussions with Juergen, we decided what we have in our portfolio. So when we're talking about products, not a platform itself, so we're talking about each of this kind like Lego bricks. So you have Tanzu Application Platform, you have Tanzu Application Service, Tanzu Kubernetes Grid, Application Catalog, Tanzu Mission Control, ARIA Operations for applications, and how they stick together so that we build a consistent platform for all the requirements that we need. So and that looks so that we going to like the Kubernetes infrastructure. So we build this on top of our different like Cloud Foundation, VMC on AWS, and vSphere, for example. And on top of that, we have our supervisor cluster, and over that, so all the namespaces we need and provision all the kind of infrastructure and the storage behind that. So and then we go further to have the application catalog. So that's the solution that we have upstream open source components in there that the developers could use and on multiple platforms. And choice of infrastructure, so that's really easy to use that. And then we go further to the Tanzu Application Service. So we integrate this in the development space so that the developers could easily consume the platform. So the complete infrastructure could use the build packs, for example, in that kind of ways. And the infrastructure is complete agnostic down there. Yeah. So, and that's the point, how we manage Kubernetes clusters itself with Tanzu Mission Control on it. So that's the reason why we could use different Kubernetes infrastructures. With Tanzu Mission Control, we have the policy management, we have the cluster lifecycle management, the application catalog, and we could use it on all the different infrastructures like VMC, edge computing, for example. So, and that's really the single pane of glass on top of it to manage the different kind of Kubernetes clusters. And then comes the point how we monitor this, how we find issues, errors, and so on. So that's really, with ARIA Operations, we have a solution that we could use beside on the infrastructure. Then on top of the management layer of the infrastructure, like vRops, for example, and we realize automation. And after that, we could integrate this in our, I would say, in the developer platform, for example, to integrate this in the different kind of containers of the pods and in the applications. And it's really easy to show the development team how they want to use the different kind of ways. So which metrics. So when the database is going slow, so we have different kind of response times, for example. And what are the metrics? So when you define that, so and the possibilities here. So we use here Tanzu observability. And get all the kind of metrics and all the kind of information in that application and front end. So that's really easy to analyze what's going down, what's going up. I have longer response time. I need some more Kubernetes clusters, for example. So that's really easy. So, and then we're going on the Tanzu application platform. So that's the layer or the point that the developer comes from here, from this kind of ways, and says, okay, I have a portal and I can use all the kind of service, and I don't care about the infrastructure down there. So that's the other layer behind there. So that's the infrastructure layer, and that's I would say operational layer for the developers, for example. And then we go on the different kind of services they consume. The applications could use the build services, the pipelines, the workflows on that, the APIs, for example, and that's all running on the same consistent infrastructure. So, and that's we coming to the point and say, okay, so we don't picking any kind of this different Gits or some solutions from the cloud native front end. Yeah, so then we go to and say, we're talking about a platform for application engineering. So that's the point. So when we're talking to each other, so Juergen and I, so we decided, so that's platform engineering, for example. So when we look at, I would say, in our marketing at VMware, so everybody talking about platform engineering, for example. So they're talking about, we have vSphere, we have VCF, for example. Then we have some observability solutions. We have TAS, TMC. And when we stick this together, so we're building the consistent infrastructure complete on the same technology, like in the public cloud, VCF on the edge. And then we have the Tanzu Mission Control for managing the Kubernetes infrastructure. On top of this layer, we have some security stuff like NSX, for example. And then we have the layer for the developers, or the services for the developers, like TAS, the build and the CI/CD services, the application catalog, the Git repository, all on that. And the front end for the developer is the portal that they get and can consume the services, and they then don't care about any different applications and solution on top of that. Yeah?
So basically, you use all the different VMware products, which are building blocks, and you stick them together to a platform that suits your needs. You may not use all of them. Maybe you just use Tab, you just use TAS. Maybe you don't need the app catalog, but at a sum, they will form something that is greater than the individual products itself. It's the platform you can offer to your development teams that will help them create their applications to the customer.
Yeah.
Okay?
Yeah.
And with that, you will reach maybe not the 90% productivity, but you will be able to reach a productivity, let's say you can spend 80% of your time, 4 days a week, just coding your application. The rest is done by the platform, the automation and the tools in the platform, and your developers can focus on creating what delivers really value. That requires more than just tooling. It also requires a good documentation and self-services, and usually doesn't end at the boundaries of the platform you can build with this Lego building blocks. It also requires a bit tackling all the infrastructure around your platform, like existing processes, ITIL processes, and what else belongs to that. But you will be able to reach that. Obviously, you cannot avoid meetings. You will have to have some meetings at all. You will have to talk to some colleagues as well, and you will have to manage some set of infrastructure. But it's a reduced set of infrastructure. So the essence is treat your platform as a product and build it for your developers' needs. And with that, I want to have you some takeaways. Visualize what you want to achieve. Find common bottlenecks and create self-services around. Find these friction points where your developers struggle. Look what a tool maybe can help you at this. And find the right developers. Find the right tool to make developers work easier. Remove paper forms. Paper forms are always a hassle because when I'm a developer, I want it to have that service and I want to have it now. Even if it's just the 90% solution, 90% solution that I can get now is much better than a 100% solution that I have to order for 2 weeks. Platform as a product. I always tell this, and when you think of your platform as a product, you have to talk to your customers, to your developers, to understand their needs and to understand what you can do better to help them fulfilling their job. If you treat your platform not as a product, you don't treat your developers as your customers, you treat them as your users. Users have no choice, they have to use, and you don't have a motivation to make your platform good. So that's why I always talk to my developers as my platform customers. And talk to them. Talk to them really often to understand what are their needs. Maybe try to understand this developer piece of mindset, which is somehow not common to the infrastructure guy mindset. And I've been on both sides of the wall, you know. So even in large enterprises with a lot of regulations, you can work as efficient as a startup. You just have to create the platform, and the just might be a bit bigger. And with that, I want to thank you. Please take the survey. And if you have any questions, feel free to ask.
Yeah.